Solve the system of two linear equations, ax plus by equals r, cx plus dy equals s, with two unknowns x and y. Using substitution methods, first we isolate y using the first equation, by equals r minus ax, so that y equals 1 over b times r minus ax. This is r over b minus a over b times x. And then we plug this into the second equation, cx plus d times y, but y is now r over b minus a over b times x equals s. We then distribute and simplify. This is cx plus dr over b minus dA over bx equals s. We then combine like terms with x. We then factor out x to get c minus dA over b equals s minus dr over b. We then simplify this fraction. This is b in the denominator, bc minus ad equals b, this is bs minus dr. And so, isolate x, we have x equals bs minus dr over b times b over bc minus ad, because dividing a fraction is the same as multiplying its reciprocal. B canceled out. We have bs minus dr over bc minus ad. This is x. Once we have x, we can use back substitution and find y. Y is r over b minus a over b times x, but x is now bs minus dr over bc minus ad. Simplifying this, we have r over b minus a times bs minus dr over b times bc minus ad. Then we find the common denominator. The common denominator is b times bc minus ad. So we take r times bc minus ad minus abs plus adr. This is rbc minus rad minus abs plus adr over b times bc minus ad. And we see that we can cross out rad negative and adr positive. And so we obtained rbc minus abs over b times bc minus ad. And we factor out b in the numerator to get rc minus as over b times bc minus ad. And so we obtain y equals rc minus as over bc minus ad. But what are these expressions? X equals bs minus dr over bc minus ad, which can be written as dr minus bs over ad minus bc, where we multiply -1 to the top and bottom. Y equals rc minus as over bc minus ad can be rewritten as as minus cr over ad minus bc. And we see that AD minus BC is actually the determinant of the matrix A, B, C, D. This is the coefficient matrix of the given system of equation ax plus by cx plus dy. So that is the denominator. The denominator is the determinant of the coefficient matrix. Next, we see that the expression as minus cr is the determinant of the matrix. As is the product of the diagonal as and then cr, a times s minus c times r. But ac are the coefficient of x and rs are the constant on the right hand side of the equal sign. And then lastly, dr minus bs can be rewritten as r s b d. R times d minus b times s, where bd are the coefficient of b. For this reason, if we let d be the coefficient matrix a, b, c, d, and we let d sub y be the matrix where we swapped the second column, which is the column for the variable y, by the constant on the right hand side of the equal sign, rs, and d sub x is the matrix where we swapped the constant on the right hand side of the equal sign instead of the coefficient in front of x, so rs b d. Think of it as we take the matrix D and we replace the y column by rs and the x column by rs to obtain d sub y and d sub x respectively. Then the solution x is dr minus bs is d sub x over ad minus bc is d, and this is the determinant of dx over the determinant of d. Y equals as minus cr, which is the determinant of d sub y, over ad minus bc, which is the determinant of the matrix D, where d, dy, dx are these matrices. And this result is known as the Cramer's rule.